Okay. Just a reminder from last week, and we will look at these quizzes tomorrow. But we had these formulas for the Arc-Lincoln area of a sector. Given is a find the area of the sector with a simple angle of 2 radians, and that's always a little uncomfortable for people. We are going to get to the point where we feel like radians should have a kind, does not have to. But that is the key to the radians, or to the theta that is in each of those formulas, that they are in radians, and this one is. So we know that the central angle is already in radians. We don't have to convert. That was kind of the big thing on your quiz, is that you did recognize to convert it if needed. And then they tell us the radius is 10, putting that into the appropriate one. The area of the sector should have been this formula here. 1/2 times 10 squared times our central angle of 2 is 1.0 into square. Okay. Any questions from that old stuff? All right. Today, again, kind of building into a new, we are going to look at kind of the foundation of this whole idea of the circle. It is all based on the straight function. We're going to talk a lot of. So this a lot today, setting up our ratios based off of our right triangle. So today we're going to use the definition of our straight function to find any angle. We're using a specific angle, so we'll kind of narrow it down when we get there. But it's the underlying idea behind this. And we're going to really focus on what sign my answer would be based on where it is falling in my picture. What does that mean? Thinking about moving right, left, up, or down, and those other terms that are making this number in our program. Okay. Okay. Looking at a right triangle drawn in quadrant 1. So if you know your quadrants, it goes 1, 2, 1, 2, your direction here, 1, 2, 3, 4. As you move around a circle, how we get to that location. So if I were given some point x, comma, y, and I fell in that point, put me into quadrant 1, what would you know about the values of both x and y? They're positive. Right? That's how we get into quadrant 1. We move right is positive. We move up is positive. Which means what do we know is true about our values of x and y? They are both positive. Okay, now I want to give you a little bit of notation here that you're going to see. We will refer to those movements right and left is always our x value. Up and down is always our y value. And if I were to trace my way to that point, this point here, x comma y, I trace my way there. I get this line across the bottom that we call x. I get this line up the side that we call y. If I then connect that point back to my origin, it completes this right triangle. The angle at the origin is always going to be theta. So when you're asking about the trig ratio, sine, cosine, any of them, for theta, theta is always located at your origin. So when we connect back to the origin from our point, theta is located there. And then I want to talk about this. It says R. That is a common mathematical notation, and it seems kind of like a weird random letter sitting there. The reason it's called R is because if I were to draw this separately here, okay, so I've got this point, x comma y to get there, and then over x plus y, connecting back. We call this R because if I were to draw this circle that went through that point centered at our origin, that length there that connects back to our origin would be the radius. Okay. A couple notes is that value is always positive. It doesn't matter, and we'll look at here, but that is always a positive value. A radius is a length. So regardless of what x and y are, R will be positive. Okay. So if I then draw that right triangle by tracing my way to my point x comma y and connect back to my origin, and we get this picture of a right triangle, look at what we could say about the trig functions based on those letters. From theta, this would be my opposite side, my adjacent side, and my hypotenuse. Knowing that moving right and then up creates that right angle. Okay. And so then, what would my trig functions be? Well, sine would be my opposite side over my hypotenuse, which would be our y value of that point over whatever the hypotenuse of that triangle ends up being, so the x squared plus y squared square root of that. Our cosine would be whatever our x value is over our hypotenuse. And our tangent would be our opposite over adjacent, which is that the x of the y value of our point over the x value of our point. And then our cosecant, secant, and cotangent would take each of those and turn them upside down. Cosecant being the reciprocal of sine, so our hypotenuse or the radius of our triple over y. Secant being the reciprocal of cosine, so our hypotenuse over our x value. And then finally, our cotangent would be the reciprocal tangent, so our x value over our y value. Now, I'm going to show you a very specific situation where I rely on this to be true. I like the visual, so we're going to draw all of these and use the visual. Basically, this would allow you not to have to do that. I don't think it's worth it to like memorize those ratios or anything. There's one specific situation down the road that is going to help us, and we'll just go back to this eventually to help us with that idea. Okay, so then those ratios don't change, but what changes is the signs as we move from each quadrant. So let's talk about the three other quadrants that we have. What if my ordered pair, my x comma y, put me into quadrant 2? Well, how do I get to quadrant 2 for my origin? I have to move left and up. So what do I know about my x value? It's negative, right? How about my y value?
Positive.
Positive. Right? I moved up. So I know this is a negative number and I know that's a positive number. Okay. How about getting into quadrant 3? Left and down. Negative, negative, right? I would have to move in a negative direction and then another negative direction. Negative, negative. And then finally, to get into quadrant 4, I have to move to the right and then down. Right being positive, down being negative. Okay. The signs are going to become incredibly important to us. We're kind of building up to a shortcut of what is always positive and what is always negative based off of how do you get to each of those quadrants. And then have that create that triangle in there, and then those ratios are always the same number over the same number, and whether that always turns out positive or always turns out negative. Okay. Questions so far? So, as you guys are, some of you are still copying this down, that is how we're going to start these problems, is that you will start by giving yourself an x and y-axis. Okay. I will start my pencil at the origin, and I will trace to whatever x comma y they tell me. Okay, so if my x comma y is maybe a negative x and a positive y, I just trace myself to that point. Normally we would not have like drawn the lines, but now we do. Because now if I connect that point back to my origin, it will appropriately draw the correct right triangle for me. Okay, trace your way to it. Basically, we know how to get to those order pairs, now you're just going to draw and you do it. And then connect back to your origin, and theta is always at your origin. Okay? Okay, this sums up everything we just talked about. Hopefully you know that that is algebra review. But that's why I'm going to know which quadrant I'm going to focus on. I'm not going to necessarily draw the whole thing every time. Like I'll draw just a quadrant 3 for myself because I know based on the fact that it's 2 negative numbers that that's where I'm going to end up. Okay, and that's our whole discussion at the beginning of this: is what quadrant are we located in? That could be by our ordered pairs here as we get started. Questions for me? Second here. All right, So this chart right here, and I'm going to refer to this as like the chart. It is true. And as we move to the different quadrants, like maybe our x value becomes negative, so then our cosine value becomes negative. Or maybe we're in quadrant 3, so both our x and our y are positive negative. Well, if both our x and our y are negative, that becomes a positive number for your tangent. This table right here that we kind of wrote down at the beginning is not something that you have to memorize ever. And again, like I said, I think we'll look at the picture of the triangle more than we will this particular chart of values, except for in one specific situation. And again, and this is only something we will rely on until we get to know our unit circle. We're building up to our unit circle. And that is true for every triangle, regardless of what quadrant we fall into. Our x or our y value of our coordinate over the hypotenuse of that triangle will always give us our sine ratio, regardless of where we're looking. This is a key point here. It does not matter what quadrant you are in. The hypotenuse of that triangle is always positive. Always, 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 always. Okay? So don't ever put a negative number on it. If you end up with a negative answer, something is wrong. You should always have a positive value regardless of the quadrant. Would anyone still like this? Yes.
All right, we ready? Okay. So how are we going to attack problems like this? What we're going to do is we're going to start with given a point that falls in our coordinate plane. This is the way it will be worded. It's saying it's creating an angle. So it says that the point 1, -3 is on the terminal side of our angle theta. So what we need to do is figure out, okay, 1, 3 is positive, negative. What quadrant is that going to put us into? 4. Okay. So I am going to trace my way. I'm going to give myself a coordinate plane to look at. I'm going to start my pencil at the origin. And I'm going to trace my way to this point P, which is at 1, -3. So that's what you're going to start with. Start at the origin, trace to the right 1, down 3. Okay. Start at origin. Once I have done that, I'm going to now connect back to the origin. So I was here, right? Now I'm going to connect back to the origin and put theta at the origin. Okay. Label your triangle. Exactly what we just did. From the origin, I moved to the right 1. That has a length of 1. Then I moved down 3. That has a length of 3, but negative because we had it down, right? So label and then use Pythagorean theorem to find the missing side. It's just the right triangle, right? So that's how we find our missing side. Again, reasons that we were practicing that earlier. Okay, so in this case, now here's what you need to understand. Again, this is a negative number. But when I square a negative number, it always comes out positive, right? Make sure, and I would not even type the negative in my calculator, or you need to be careful to put parentheses around it, because if I forget the parentheses, it's going to try to tell me -9, which it is not. Okay, I would leave off all negatives at this point. Type in 1 squared plus 3 squared. 1 squared is 1, 3 squared is 9. Add those together, we get 10. Or that our missing side is the square root of 10. always positive. Questions? Okay, so then let's find each of the 6 trig functions. So we know we have 6 answers at this point. We have done all of the legwork. Now you just have to look at the picture and say, what's my opposite over hypotenuse? What's my adjacent over hypotenuse? All of that. So think through SOHCAHTOA to start with, right? And do your sine, cosine, and tangent first, just because they're the easiest. Sine, so theta, again, is always at our origin, which would make this opposite, adjacent, and hypotenuse, which matches what we just talked about, that our y value over our r value is our sine. That's why I think the rectangle, or the triangle, I don't know why I call them rectangles, the triangle is a lot easier than trying to memorize that chart, because we already know how to do this at this point. This is an old problem now. The only thing we have to be careful of is we don't leave a radical on the bottom of our fraction. So go ahead and rationalize this. You do not have to show this work if you are at the point where you can look at that and know what the answer is going to be. Once you rationalize, just go ahead and do it. Yes. Yes. Keep going through our picture here. Cosine is adjacent over hypotenuse, so 1 over r squared of 10. Rationalize. Notice that one is positive. Both your x value and your radius are positive on this one, or hypotenuse, whatever you want to call it. Tangent, opposite over adjacent. Questions? There's 3 answers. We're supposed to have 6, so now I need to do the reciprocal of each of those. I will remind you that as you're doing your reciprocals, if you had to rationalize like we did on sine, that I would go back to this unsimplified version and just turn it over there. It's just going to save you a little bit of time on the work part of it, so I don't have to rationalize twice. If I turn negative 3 over square root of 10 upside down, I get negative square root of 10 over 3. Or go to my picture and do hypotenuse over opposite. Secant, reciprocal of cosine, and again, because I had to rationalize this, I would go to the unsimplified version and turn it upside down. Square root of 10 over 1. And cotangent is the reciprocal of tangent, 1 over negative 3. What questions do you have for me? Okay. This time I'm going to give you a second to try to draw the picture on your own before I put it up on the board. Same question. P is negative 2, negative 5 on the terminal side of our angle theta. Find the 6 trig functions of theta. Put your pencil on the origin, trace. Now it's important that you remember your algebra for this because we have to do right and left first, and then up and down second to correctly draw this. What quadrant? Good job. Okay, so if I start at the origin, negative 2 means to go left 2. Negative 5 means to go down 5. Connect back to the origin. Theta is at the origin. My next job is Pythagorean theorem to find my missing side. Yes, I can put the negatives in there, but make sure that either you put them in parentheses or that you don't type the negatives in your calculator. So 2 squared is 4. 5 squared is 25. We're adding those together, so 29. We will always simplify these radicals. You will never get a decimal. However, there's no perfect square that goes into 29, so it doesn't simplify. It will just stay the square root of 29 positive because all hypotenuses are positive. Questions? Okay, so theta is at our origin always. So in this particular picture, that would make this side my opposite, this side my adjacent, and my hypotenuse is here. Set up your trig functions. Sine is opposite over hypotenuse. Rationalize. Cosine, adjacent over hypotenuse. Rationalize. Okay, this one you'll notice tangent, and this happens in quadrant 3 every single time. Tangent is your opposite over your adjacent, which is a -5 over a -2. But when you have a negative divided by a negative, it comes out positive, right? So I would simplify that to a positive 5/2. Questions? Okay, so then we just need our reciprocals of each of those. Oops. Cosecant is the reciprocal of sine. I'm going to go to my unsimplified version and turn it upside down. Secant is the reciprocal of cosine. Same thing. Go to my unsimplified version and turn it upside down. And tangent, oops, cotangent is the reciprocal of tangent. Starts out as a -2 over -5, and a negative over a negative is a positive. Any questions for me? Okay. As you are doing this, I want to just give you a little helpful hint of the 6 trig functions in quadrants 2, 3, and 4. 4 of those answers should be negative, only 2 should be positive ever. Okay, and eventually we'll know exactly which 2 based on what quadrant we're in. Quadrant 1, everything's positive. All 6 answers should always be positive in quadrant 1. Okay. All right, so what happens if the ordered pair they give us falls on an axis? Okay, well, the problem with this, so these are called quadrantial angles, meaning they fall on an axis, is that I can't draw a triangle. If I trace my way to that, so the ordered pair is 0, 1, and I put my pencil on the origin and I trace right or left 0, up 1, and I connect back to the origin, I have a straight line. I don't have a triangle. And that's where this one kind of falls apart with our whole draw the triangle and go back to what we know thing. Because we don't have a triangle if it falls on an axis, ever. And so what happens is our R value, which was our hypotenuse, will always equal whichever right, left, up, or down that we actually did travel away from the origin, because again, that R refers to the radius of the circle drawn through that point. Okay. What? That was a really good circle. Circles are really hard to draw. That's a really good circle. No, I was actually going to compliment myself on that as well. They're hard to draw, and that's actually a really good circle. We can just take a second to admire that because it's probably not happening again. So how do we do this if we can't draw a triangle? This is where we do need to rely on this table, okay? So if you maybe failed to get this little chart in your notes earlier, you're going to need it at this point, because right now, today, the next couple days, we don't have the tools to answer these questions without this chart. And so what we have to look at then is the fact that this is our x, comma, y, and that r will equal one of those 2 values, whichever one's not 0. Okay. In this case, our radius would equal 1. Okay. And then I set up each of my ratios based off of that chart. Okay, questions so far? So when I refer to that chart, this is what you're going to be looking at. And eventually we will get away from this, and I will show you how and why eventually. So how do these values compare to the point themselves? So let's look at the values that we have up here. Okay, so if our radius is the same as our y value, Sine is our y value over our radius, which is 1. Cosine is 0 over our radius. Ooh, how does 0 over 1 simplify? 0. Okay, and our tangent, ooh, this one's also a good one for us to talk about, is 1 over 0, our y value over our x value. What does that simplify to? Undefined. Okay, these two little simplifies right here, very important for you to understand. With the 0 on the bottom, that's undefined, but the 0 on the top is 0. Okay, now turn each of those fractions upside down. 1 over 1 is 1. Okay, now this one becomes 1 over 0, which we talked about over here. 1 over 0 is undefined, right? And cotangent becomes 0 over 1, which is 0. So what I want you to look at is, most specifically, our sine and cosine. Look at our answer for sine, and how did that compare to our ordered pair? It's your y value, right? Sine was our y value. How did our cosine answer compare to our ordered pair? It's our x, okay? What we're going to find out eventually is that's not going to change. Your sine will always be your y value, and your cosine will always be your x value today on our axis, eventually for each of those ordered pairs. Okay, so let's look at just all of the options for what can fall on an axis. Okay, you will think through this picture over and over and over and think through, and I always use just a 1. How can I get to some point on our positive x-axis? I go to the right, a positive 1, up or down 0. How do I get to something that falls on that positive y-axis? Well, I would go right or left 0, up something, up 1 for right now, we'll call it 1. How do I get to the negative x-axis? I go left 1, which is why it's a negative 1, up or down 0. And then how do I get to that negative y-axis? Well, I go right or left 0, and then I go down 1. What angles do those correspond to? I have listed. In the blue, I have listed your degrees. And remember that we can expand that list by continuing to add 90 each time we go around, right? 90 degrees, 180, 270, 360. What would that be? 450, 540, 630. We can add, we could keep going, right? We just keep adding 90s each time we move to the next axis. In radians, we have not talked this very often, but to fall on an axis, it either has to be pi or 2 pi, or some multiple of that, or it has to be half of that distance, meaning it will be something over 2. Every time you fall on an axis, it's going to be something pi over 2. This would be 1 pi over 2, 2 over 2, which is 1. 3 over 2, 4 over 2, 2 pi, 5 over 2, 6 over 2, 7 over 2, 8 over 2, 9 over 2, 10 over 2. You get the pattern here? Every line we move to is another over 2. Simplify the fraction. Okay? Everyone got this picture down for yourselves? All right. So what could these questions look like? Well, instead of giving us an ordered pair to look at, they're going to tell us which axis to look at by telling us what angle we are looking at. So they say evaluate if possible. This particular question says the cosine and the cosecant. So we're going to do 2 problems each time based on the theta they give us. So they're saying what would be the cosine if theta was 0 degrees or 0 radians? Degrees, radians, okay? So if we were doing the cosine of 0 or the cosecant of 0, that's what we're doing on this first one, that would be this angle over here. This is 0 degrees, 0 radians. It means utilize this picture right here, okay? So that becomes our ordered pair. Here's my x comma y that I will use. Remember that for all of these, our radius will be 1, whichever one has a value other than 0. And this is where I'm going to tell you, go back to the chart. And I'm going to have to flip back a page because I don't have the chart side by side here. But if I go back to my chart, we were supposed to be doing, oops, a couple pages here, cosine, which is supposed to be x over r, and cosecant, which is r over y. Okay, let me translate those to our page here. We just set up those ratios. So cosine is x over r, 1 over 1. And we'll always match whatever your x value is in the ordered pair. Cosecant will not. Cosecant is going to be our r value, which is 1 over our y value, which is 0. And then we have to remember how that simplifies, and 1 over 0 is always undefined. So this is when it falls on an axis, that's when I'm going to tell you to rely back on your chart. Okay. So let's do another example here. At 90 degrees, okay, cosine of 90, you can write 90, you can write theta, you can write pi over 2, it doesn't matter, those are all the same question. Means we are looking up here. This is 90 degrees or pi over 2 radians, so we would be using an x value of 1 and a y, or sorry, an x value of 0 and a y value of 1 this time. Good. Okay. Cosine is x over r, still going to be 1, so 0 over 1. Cosecant is going to be r over y, or 1. Questions? Okay. You try out 180 and 270, and I'm just going to come around and help. I'll put answers up here in just a second. All right, so again, correctly identifying the right point to use based off of the angle listed, 180 and pi, we're both indicating that we should be looking at this negative x-axis, which means my x value is -1, my y value is 0, r will be 1 the entire time. So cosine of whatever you want to call it, theta, pi, 180, is -1 over 1, which is -1. And cosecant is our r value 1 over our y value 0, which is why I will say it is undefined. On an axis, you can only get 4 different answers, 1 and -1, 0 and undefined. You cannot have any other answers besides that, okay? So if you are getting other answers, double check your work because it should not be happening. All right, our last option should have been the negative y-axis here. 270 degrees, 3 pi over 2 in radians. Cosine there would use our x value over our radius, which should have been 0. And our cosecant was our y value, or sorry, our radius over our y value, which is -1. And again, I picked those two functions because that's specifically what the question asked us. Maybe it asked us for sine and secant or tangent, whatever it asked for. We can do that, but that's the process of how you would go through that. Rely on that chart when it falls on a quadrant right now. Any questions for me? All right. Your assignment today is on My Math Lab. Yes.